In this video, we're going to talk about a common misconception and how to avoid that common misconception when you are teaching with problem-based lessons or when you're teaching through problems. We're going to talk about that in this video so that you can help your students as best as you can think deeper. Let's go. Hey there, Math Moment Makers. John here from Make Math Moments. And if this is the first time you've been to this channel to watch a video just like this, hey, don't forget to hit the subscribe button here on YouTube. So we have videos that come out every week on tips, ideas, lessons, tech tips as well for you to make a difference in your classroom and make math moments that matter. Here in this video, we're going to talk about a misconception around problem solving and teaching through problems, and I want to do that with you with an example on exponents and introducing exponents to your students, or exponential expressions with your students. And I just want to start off by thinking about what we've been talking about here on the YouTube channel, and also in our podcasts, and also in our lessons. We talk about the curiosity path as a way to generate curiosity for our students. And that's, step one in making math moments that matter is, how do I generate curiosity for my students? That builds into the second piece, which is fueling sense making. How do I fuel sense making for our students? And when I think to how, this major misconception when we teach with our students, a lot of times we think we have to lay the groundwork for them. We have to help them as much as possible. And hey, we got into teaching because we wanted to help kids, and we thought maybe that laying all that out for them would help them so much. But came to realize through the teaching of my career that helping them too much, it prevents them developing a sense of ownership in the math that they're doing, a sense of understanding the math that they're doing. Getting them to do the thinking is more important than, say, you laying it all out for them. And I think having your students go through some of that struggle is what really helps them the most. And I know that's tough for us because we tend to want to lay everything out real easy for them. I try to now in my career try to put them in situations that are, one, curious, two, allows them to struggle a little bit so that we can fuel sense making. And I want to show you a lesson here on exponents that I did this week that I've never done before. I saw it in the last couple weeks. I want to show you where I found it and also how I used it with my students. It turned out great, and I would use it again. It is a great lesson that is a little bit curious, a little bit mystery here, but also sense making is definitely happening along with thinking in my students. So let me just show you kind of like, this is what I used to do, when I first taught. I would just say, hey, look, there's no curiosity here. I would just say, today we're going to learn about exponents. Hey, here's an exponent. Here's a power. Here's how you write a power in expanded form. Here's who it evaluates to. And that's quick. That's quick and easy. Now let's evaluate some. Let's rewrite these in expanded form, and then we'll evaluate them. Let me do A. We'll do B. We'll do C. Hey, maybe you can do D. That's the way I taught for a long time. And there's no thinking here. There's no curiosity here. So I'm going to switch here and show you the lesson that I've used, and I'll show you where I got it a little after. Okay. So this lesson is a simple idea. Okay, so this lesson, very simple idea. This is the script that I did with my students. Very easy. There's no tech set up here for you on your end here, folks. All I did was I wrote the number 25. This lesson is called Split 25. And I wrote the number 25. Oh, I need a pen. I wrote the number 25 on the blackboard or the whiteboard. And I said, let's break 25 down into numbers that add to 25. Give me some numbers that add up to 25. And students would say, how about 10 plus 10 plus 5? That definitely adds to 25. I said, thanks very much. Now I'm going to take those values that added 25, and now I'm going to multiply all of them together like this. 10 times 10 times 5. And I'm going to calculate what that is. That's 10 times 10 times 5 is 100 times 5. That's 500. Awesome. Okay, can you give me another number, another set of numbers that add to 25? And students might say, okay, well, how about 20 and then 5? And I said, okay, awesome. 20 plus 5 does add to 25. Okay, now I'm going to take those numbers, those 20 and 5, and I'm going to multiply them together just like I did before. 20 times 5, and that's 100. And you'll notice that this number that I've just created is less. This 100 is less than 500. And so I challenge them. I say, can you make a number bigger than 500? Because this 500 right now is bigger than 100 by using the numbers that add to 25. So come up with a set of numbers that add to 25 and then multiply those numbers together and see if you can come up with a bigger number than 500. So students will come up with different combinations. Like these two, they'll all of a sudden try to make it maybe a little smaller. I've had a student go, okay, well, 19 plus 6. Awesome. That's 25. Okay, now do 19 times 6. See if you get bigger than 500. Another student's going to say, okay, well, 15 and 10. That does add to 25. Awesome. And multiply those two together. And I get 150. That's not bigger than 500. Okay, great. All right. So some student will say, well, 5 plus 5 plus 5 plus 5 plus 5. That adds to 25. And I say, okay, well, multiply them all together. And so they'll multiply 5 times 5 times 5 times 5 times 5 times 5. And they realize, hey, that is bigger than 500. And I said, awesome. Okay, great. Now, with your partner, head to the wall space. Grab your whiteboard, grab your whiteboard marker. Now, find me more numbers that are bigger than that number. We want to find the largest. What is the largest number we can find by breaking 25 or splitting 25 down into different numbers and multiplying those up? And what students will find is they will break them apart in this way and they'll come up with different numbers. What eventually happens is students will realize that smaller numbers, and many of those smaller numbers, like a lot of 2s and a lot of 3s, work really well in multiplying the same number over and over and over again, gets really big numbers. Hey, that sounds like exponents. So some students will say, look, I will eventually have a 2 plus a 2 plus a 2 plus a 2 and so on. And then, you know what, I think I need a 3 in there. But I need 10 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I need, what's that, 20? And then I need another 2 and then another 3, something like that. And they'll multiply those together and they get a really big number. And then we'll say, well, what happens if we use 3s or 4s or 5s? And all of a sudden students are not, when they go to multiply, they're writing 2 to the power of 10. Times that extra 3. 2 to the power of 11. I had 11 2s there. And then it times it by 3. And they're writing exponents. They're writing they're multiplying the same number over and over and over again. And they're simplifying that up by writing it as a power. And they're doing this for a while. They're doing this over and over and over again with different powers, different numbers. All of a sudden, you'll have a student who wants to use a fractional of a number like 2.3 or 3.2 a lot and see what they come up with. Or maybe 4.5 works really nicely. Or you're going to have a student go, what happens if I use a negative number? So really nice things happen when you let your students do the thinking, right? They're doing all the thinking and you're walking around talking to them about how to write it in an exponential way. Like, hey, it's shorter if I write it like this. And you get to the same conclusion of the same lesson that this lesson did. We wrote different powers in expanded form over and over and over again and evaluated those expressions. And I'm not going to spoil it for you what the right combination is because you're going to go and try it right now. I know you are. You're trying to figure out what is the biggest number and also what is the combination that makes that work. So that's called split 25. And split 25 eventually found here on MrOrr-IsAGeek's blog. One of the founders of Play With Your Math, which is a nice website that has lots of different ideas. So you'll see a different combination here. You can read through the blog post. It has lots of exemplars of what students might do. It has a full solution in there. Don't spoil it for yourself. Go and find. It has a really nice, elegant solution of what number, what power is really nice here, and you'll be surprised on what happens. So I'm not going to spoil that for you. There's that mystery, that curiosity that we were generating. Now, I also didn't find this on the blog right from this. Remember, I found this just only a few weeks ago. I had used different lessons for this before, but this one I'm hooked on for this exponents lesson. And I actually found it on our blog, which is MakeMathMoments.com. We compiled a list of different resources from different districts across Ontario when we introduced the new grade 9 program this year here in Ontario. And different districts were putting together different lessons and different ideas to help support the new curriculum. And I was searching through here a couple weeks ago, and I clicked on the Waterloo Regional District School Board's resources. Some really nice resources over here from Waterloo. And they had some course resources at the top, and I clicked on live course plans right up here. And when you get to live course plans, you can see a number of teachers who are sharing their day-to-day plan on this course. And Alita Klassen, I've met numerous times. I recognized her and I said, you know what, Alita does good stuff. Let me go have a peek. And you can see her day-to-day plan all laid out. And in this day-to-day plan, there is a split 25 right here. And that's where I first discovered this lesson, finally linked it back to the Play With Your Math website. So I'm putting all these links in the notes below, in the links below. So check that out for sure. But back to the big main message here. How can we avoid rushing to the algorithm? How can you get your students curious? How can you get your students fueling their sense making and thinking? That's such an important change. It's been the biggest change in my career over the last 10 to 15 years. So important to make that happen with your students. How are you doing that? I'd love to know. Let me know in the comments. How are you teaching exponents? Because I'm always on the hunt for great thinking and curious and fueling sense-making type lessons as we create them over on our task website too. But let me know. Give me your best lessons below. I'll see you next week in our next video. Take care.